Hi everyone, my name is Yo Chen Lim. I am an MMH student, and today I'm going to walk you through the revenue management system I built for a 191-room hotel. You can think of this as a prototype RM engine your hotel could actually use in real life. It is not a property management system, it is not a reservation system, it is really very focused on doing one thing well. Given our data, how do we sell each of our 191 rooms at the right price to the right guest on the right night? Alright, let me start with the right. Let me start with the why. So what problem am I trying to solve? We are looking at 191 room hotel with three main price points, 159, 189 and 219, and most of our guests stayed between 1 and 3 nights. On any given day, the revenue manager is juggling different rates, different lengths of stay patterns, group asking for blocks of rooms, and the usual uncertainty around no-shows. If we manage them mostly by gut feeling, changing a rate here, guessing an overbooking level there, a few things can go wrong. We might sell out too early at the lower rate. We might underprice peak nights when demand is really strong, or we might say no to profitable group because we don't clearly see the displacement of transit demand. So the goal of my project is to build a practical RM engine in Excel, something a revenue manager can actually run every morning using the data the hotel already has. To do that, I use historical reservation pickup and no-show data from January through April. Those data fit into the model and let us answer the key question a revenue manager cares about. What should our bid price be on each night? Which date, which rate and length of stay combination should be open or closed? What is the optimal overbooking level once we factor in no-shows? And what is the right mix between transit and group business? The nice part is that all of this is automated. I set up software to run into background using VBA update button, so instead of playing with software dialogues every time, the revenue manager just click one button and the model refresh all decisions with the latest data. That is a big picture. We want to move from manual reactive decision to a consistent data-driven system. Now, we will go a little bit deeper into how the RM engine actually works. On the slide, I break the engine into 3 steps, so it is easier to digest. First, we need a good forecast. Using the project data file, I built ROH, pickup, and forecast table for each arrival data from April 6th to April 25th. I then segment demand into night bucket. For rate 159, we have 1, 2, and 3 nights. Same for 189 and the same for 219. So instead of just looking at total demand, the model knows, for example, that April 18th might have strong demand for 2 nights, 219 rate states, but weaker demand for 1 night. Low rate states. I also incorporate DBA as booking pace. They tell us for each arrival date how much demand is still expected to come in as we get closer. Finally, we look at no-show behavior on a separate no-show sheet. I build a distribution of no-show and use the critical ratio to choose an overbooking level for this hotel. For this hotel, the model recommends about 13 rooms of overbooking. We are willing to book up to 204 rooms when we physically have 191 because we expect some no-shows. So step 1. Give us expected demand by segment and an overbooking policy for each day. Once we have the forecast, we move to the optimizations. Here, the yellow decision available table is the heart of the model. Each cell is basically how many rooms do we want to sell in the segment on this data. Our objective function is to maximize total room revenue over the whole April 6 to 26 horizon. We add constraint to keep it realistic. Expected occupied rooms on any date can exceed 191 plus the allowed overbooking. We can sell negative rooms. We respect group blocks and the length of stay patterns. Instead of asking the revenue manager to build all of this in Solver each time, I wrote a VBA macro. So they just hit update, the macro calls Solver, and Solver fills into the optimal numbers in that decision table. The output is summarized in a pink block that shows for each day how many transit rooms we are selling, total rooms sold, rooms still available, and the resulting daily revenue. The last step is turning math into decision. On the availability sheet, the model converts the optimal plan into very clear open-close control and bid price by arrival date and loss. So for a tight date like April 20th, you might see the lowest 159 rates product close, while 189 and 219 stay open. On a Solver date, everything will be open. The no-show should reinforce the overbooking guidance when it is safe to push closer to that 13 rooms overbooking level and when we should pull back. And from a Solver sensitivity report, we can see each night are actually bindingly where an extra room is very valuable. So we know where to be strict with decisions, where to be strict with discount and group business. So that is engine focusing, optimization, and the practical controls. Now, instead of only talking about it, I would like to show you a short demo of the model in Excel. ROH, input and forecasting. This should take our historical reservation and build ROH pickup and forecast by rates and length of stay for each arrival date. This is the demand forecast that fits the optimization model. Here I analyze no-show behavior using the past data from the distribution and the critical ratio. The model picks an optimal overbooking level for this hotel. It is about X rooms. This is the heart of the model. In yellow are the decision variables, how many rooms to sell in each rate, loss segment on each day. In pink is the summary transit room sold, total room sold, remaining availability, and daily revenue. When I click update, a VBA macro sends this to Solver, which maximizes total revenue subject to the 191 rooms capacity and overbooking limit. Group booking sheet. This sheet compares taking a group versus keeping rooms for transit. For a 30 rooms group, the model calculates the minimized acceptable rate around $398 here and the incremental contribution, so sales knows when a group actually improves total revenue. Availability sheet. Finally, the availability sheet turns this availability sheet turns all the mass into day-to-day controls for each arrival date and rate, thus whether it should be open or closed, plus the implied bid price. This is what the revenue manager would actually use when setting rates and restrictions.